is used as a computation device. We have performed multiplication using simple addition. So the last example we'll see a subtraction alone. Okay, I'm going to do subtraction. So subtraction is like m minus n, we'll say, or m minus n, we'll say we are going to subtract subtract n from n. So it is like your tape should represent m minus 1 when m is greater than n, or it should have only blanks when m is less than n. Okay, fine. So your tape should represent m minus n when m is greater than or equal to n, and when it should represent blanks. Your tape should have only blanks when m is less than n. So this is our criteria. Now let us consider our input, logic, and my output. Input, output logic, or input, logic, and output. So let me consider 3 minus 2. So I have 3 ones. I have a delimiter. I have 2 ones, 3 minus 2. Okay, so this is my input. My output, how it should be is, all these should be nullified, and I should have a single 1 at this place of 0. We'll understand why. So all this should be blanks. All should be blank. I should have only a single 1. Okay, what is the logic I'm going to use is, whenever you see a 1, so all these are blanks, right? So whenever you see a 1, okay, change it to blank, go till you hit a blank, and change the last one to blank. Come back and change the last one to blank. Similarly, when you see the next one here, change it to blank, go over there, hit the last blank, come back one step, and change this to blank. Okay, now I've cancelled. Now I don't have anything to cancel over here, but still, if you are writing the logic, what it will do is it will cancel this to blank. It will go and scan. It will not have anything else to, okay. What it will have do is it will cancel this to blank because it is seeing a 1 here. It doesn't know if there is a 1 down the lane or not. Okay, no problem. So what it does is it nullifies this to blank, goes and checks, hits the last blank, comes, it will not find a 1 to nullify. That means a subtraction is done. Okay, so the last one that I have cancelled, okay, what it will do is it will try to write it in the place of 0. Okay, so this is the last one I have cancelled, so it will replace it with this in the delimiter. Even if you have multiple ones, if I have 4 minus 2 also, not a problem. It is hitting only this delimiter. The delimiter 0 will be transformed to 1. So how many ever ones before this delimiter, no problem. It will be still retained. Okay, so that you can see. So for here, what happens is for the last one that I have transferred, nullified, what I'll do, I have to bring it back, right? Because this nullifying is not valid because I don't have one other one to cancel. So this one, the 0 will be replaced by a 1. So I'll have this tape as output. This is for 3 minus 2 case. So 4 minus 2 also it will be valid because there could be another 1 in between, so it doesn't matter. So one was nullified unnecessarily because we didn't have another matching 1 over here. It's just matching. Match this 1 with 1, nullify both. Match this 1 with 1. So I don't have another 1 to match over here. So what I'll do is I have to revert this nullification. So instead, I don't want a delimiter anymore. My operation is done. So I'll replace this delimiter with 1. That's it. I'll get my output tape. Okay. So this is what our representation 3, 0, 1, 1 means. First, this will be a blank, 1, 1, 0, 1 blank. Okay. Again, a blank. This will be a blank, 1, 0. What happens? This will be a blank and a blank. Then I have to, so what I'll do is this will be blank, this will be blank, this will be made blank. I won't have anything else to make it as blank. Okay, no other ones will be there. So in the next step, what I'll do is I'll make this delimiter to 1. That's it. So these are the transformations. So this is how your tape will transform, and finally this is your output. Okay, so this is how my tape will look like. Okay, so this is my logic. So take the first symbol, go till you hit a blank to the right, take this symbol before the blank, nullify it. Then keep coming left till you hit a blank. Take the next one and nullify it. Okay, so we proceed to and fro. So first nullify this blank, keep proceeding right till you hit a blank, come. So here also, after this also there'll be blank, right? So hit a blank, come back and replace the last one with blank. Then keep moving left, hit this blank, come back and start reading this, nullify this to blank. Okay, so you should know when to stop. So that is why you should know when to hit and stop and change your direction of movement. Okay, so we'll just have the tape representation and we'll try to write it. Okay, so this is 1, 1, 1, then what, a delimiter followed by 2 ones. So all these sides, these are blanks. Okay, all these sides are blanks at both the ends. Okay, so this is M, this is N. Okay, M minus N we are going to do. What's the logic? I'll take this, nullify it to blank, go, hit a blank, come back, take this and nullify it again. Okay, so let us start with Q naught, our initial state. Q naught, when it sees a 1, what happens? It replaces this 1 with a blank, right? Replace this 1 with a blank. Keep moving right. Go to the state Q1. Q1 sees a 1 or 0, I don't care. Go till I hit a blank. Okay. See a 1, replace it with 1, keep moving right. See a 0, replace it with 0, keep moving right. Okay. So this 0 was of importance. It will be of importance only at the final state. Okay. So I keep moving it. In case you're very much confused, please, you can have separate state for this 0 also. In case you want to treat a delimiter separately, no issues. Have a separate state Q2. On seeing a 0, move to Q2 and then you can continue also. No issues. It's just one additional state extra. Your logic or your output or your working of the machine will not change. Just it will have one additional state. That's all. Okay. So as you practice, you know, like which delimiter you should have a separate state or which delimiter you should not have a separate state. In case you don't want to take that confusion, no issues. You can have a separate state also. Okay. It will not affect your logic. Okay, now what I see is, I go till I hit this blank, right? So when this hits a blank, I don't have to do anything. Replace it with blank, just change the direction of movement. It comes to this now. Okay, so what it should do, Q2. Q2, okay, when it sees a 1, Q2 on seeing a 1, what Q2 on it's here actually, it's in this one, not in this one. It has hit a blank, it has come back to one symbol, so it's in this one. I should replace it with blank. Am I right? And I keep moving left. I replace it with a blank, keep moving left. Okay, fine. So it reaches another state, Q3. In Q3, I should proceed further till I reach this blank. Am I right? So Q3 also, we'll have a loop that says CA1, replace it with 1, keep moving left. CA0, replace it with 0, keep moving left. So what happens? What does it change? Q3 when it sees a blank. Am I right? So Q3, when it sees a blank, what happens? Q3 sees a blank. Replace it with blank and move right. So after this nullifying, we have done it here in Q0, right? Nullifying and proceed further. I'm just going to repeat this, right? So I need not have separate states. What I can do is I can just loop back to Q0. So Q0 on seeing a 1, Q0 it's here now. Q0 on seeing a 1, what happens? It nullifies it too. So Q0 is here now. Q0 nullifies it. Okay, goes to Q1, moves right. Now I'm at Q1, I'm here. Q1 seeing a 1 or 0, no problem. Q1 goes till it hits this blank. Now Q1 here on seeing a blank, replaces it with blank and moves to state Q2 and to the left. Q2 on seeing a 1, what should it do? It should replace it with blank. Q2 on seeing a 1 replaces it with blank and it should keep moving left. Q2 doesn't have to worry about zeros or 1. And when it sees what? So it need not worry about. So 1 I've replaced with blank. I'm in Q3 now. I've changed to Q3. Q3 need not worry about the 0 or 1. It keeps moving left. It waits till it hits this blank. So when it hits this blank, it comes over here and starts this Q0 iteration again. So now remember, listen carefully. Just to remove all this so that we understand this last cancellation is something a bit special. So we'll just take it. Okay. Now, okay, it has moved till it hits Q3 is moving back. It has hit Q3, has hit this blank. Okay, what it does is it enters Q naught, it goes to Q naught. Q naught sees this one. Q naught doesn't know if there is a tallying one here down the lane or not. It doesn't worry about it. It just changes this to blank and it keeps moving right. Am I right? So it keeps moving right. Okay, so now what happens is I go to where? I go to Q2. I mean, Q1 continuously what it does, it loops and what happens? I just have to wait till I hit this blank. Okay, I have to hit this blank. So when I hit this blank, what happens? Q1, when it hits this blank. So what happens? Q3, I was in Q3, then I entered Q naught. When I was replacing this, I would have been in Q naught. So Q naught sees this one replaced with blank. Okay, then it proceeds further. Q1 sees the zero, ignores, doesn't do anything. Q1 sees this blank. Okay, goes to state Q2. Okay, Q1 sees a blank means replaces this blank with blank, goes to state Q2, and what it does, moves left. Am I right? It moves left. Right, now Q2 sees this zero. Okay, so Q2 sees this zero delimiter. Q2 sees this zero delimiter means subtraction is done. Subtraction is done. But this last replacement is imbalanced. Okay, last blank is imbalanced. Okay, so we are in this status now. Okay, okay, so what I'll do is Q2 on seeing a zero, okay, just replace that zero with one and move left. Left or right, anything. And this will be Q accepting state. This will be what? Q accepting state. Okay, fine. So what we did, we have replaced this one, but I don't have a tallying one down the lane. That means Q2 sees this zero. Q2, when it sees a zero, that means subtraction is done. I don't have to do anything further. So what I'll do is, I'll just replace this delimiting zero to one. In order to balance the last cancellation that I've done unnecessarily, just include this one. Replace the zero with a one. That means my tape is now fine, right? All blanks, it has only one. 3 minus 2 is 1. Okay, so this case, the whole thing that we have seen so far is for so for the whole case that we have seen so far, this whole diagram is for m greater than or equal to n. So this part, complete part is like m greater than or equal to n. Okay, so this is for m greater than n. Okay, so when my case is m less than n, so what happens? Let me take, I have a 2 this side and a 3 that side. 2 this side, 0 followed by 3 ones. Okay, let us quickly consider. This will be blank, this blank, this will be blank, and this will be a blank. Am I right? So when it sees it, now I'll come to Q naught, I'll be in Q naught. So this subtraction is, I'll come to Q naught, but Q naught will be seeing a 0 in this case. Q naught will not see a next to 1. Okay, Q naught, when it hits a blank and it comes forward, Q naught previously, when m was greater than n, so when m is greater than n, Q naught will be seeing a 0. I'm sorry, will see a 1. It will not see a 0 because it will have more bits to proceed when m is greater than n. When m is less than 1, n, Q naught will not have any more 1s. Q naught will see a 0. Okay, so I should write a separate transition saying Q naught on seeing a 0. Okay, what it should do? What should be the output? You need not have anything. When m is less than n, the operation is invalid. If you have seen in the previous slide, I would replace the whole thing should be blank. Okay, so your output is like all things. These two are already blank. I have a 0, I have a 1, then I have 2 blanks. So I have found that imbalancing 1 is here, but Q naught is seeing a 0. That means m is less than n. So I should make everything as what? Blanks. Okay, so just replace it with blank and proceed to the right. I go to say Q4. Q4, how many ever after this? You might see multiple ones. Okay, right? I might see multiple ones. So how many ever ones I see? I'm sorry, I'll replace it with blank and I keep moving right. So what happens? This will be replaced with blank, this will be replaced with blank. I'll reach a final state. So when you see a blank, blank, right? So this is Q accept. Fine. So this is the diagram for subtraction. So this part of the machine, handles m less than n. This part handles m greater than n. This handles m less than n. So m less than n means you make all as blanks. Okay, m greater than n part is handled in the upper half, and this left half handles m less than n case. Okay, so this is what we do in subtraction. Okay, so